Hello guys, this is Group 8, which consists of Adriana Velasquez, Lisa Ceja, and me, Clemente Delgado, and we will be going over our design project, beam and columns. We have been asked by the City of Fresno to design a beam and two columns supporting part of a shade structure for a city park. Our given values to complete this task were 2 feet for length 1, 4 feet for length 2, and 2 feet for length 3. The columns consisted of a height of 10 feet. They told us that there would be a 200-pound point load at half a foot from the left and a distributive load of 75 pounds from 2 feet to 6 feet. They also told us that there will be a moment at the end of the beam, which is at 8 feet, with a moment of 1,000 pounds per feet. To conclude, they state that column 1 left is fixed pin and column 2 right is pin pin. On the left, we have displayed our beam with all the given values, and on the right, we have the free body diagram of our beam. As you see, based on our calculations, we have determined that AY is 175 pounds and BY is 325 pounds. On the right, you will see our completed shear and moment diagram with an absolute shear of 325 pounds and an absolute moment of 1,000 pounds per feet. We experienced a shear of negative 200 pounds from 0.5 feet to 2 feet, and from 2 feet to 6 feet, it is linearly decreasing from negative 25 pounds to negative 325 pounds. And we also experienced a bending moment of negative 300 pounds per feet at 2 feet and negative 1,000 pounds per feet at 6 feet. We compared our shear and moment diagram with an online calculator, and we got the same results. Now I will pass the mic to Adriana.
Hello, my name is Adriana Velasquez, and I was tasked with designing the beam section and fastener spacing portion of our design. Based on our free body diagram, you can see that the biggest value I would have to consider for the 2x4 placement was the moment at the right of the beam. At 1,000 pounds per foot, it's going to cause the beam to concave up. To counter this action, the base of the beam will be constructed with 3 2x4s, as you can see by shape 4, 5, and 6. Beams 1, 2, and 3 were added to increase the cross-sectional area of the beam so that our Q and I values wouldn't cause our normal stress to exceed the 500 psi limit. Before I reached my final design, I actually configured about 5 other designs, and while I was working through the math for each one, I realized that I needed a fast and accurate way to calculate these formulas, and so I created an Excel sheet, and in this slide you can see a screenshot of the Excel formulas and the formatting that I used in order to come up with this final design. Once the design had met all the design criteria mathematically, I moved on to graphically representing the data. In this slide, you can see all the values which were determined by the various formulas I used in Excel. To determine the nail placement and spacing, again, I used Excel to come up with the configuration that you can see in detail A. There was a lot of equations and a lot of math to be done, so Excel was just the best way to execute that. The final step in fastener placement was determining the fastener spacing along the 8-foot span of the beam. I used our shear force diagram to determine our values as shown in detail A. And that concludes the cross-sectional design of our beam and its fastener placement. Thank you.
I'm going to be giving the results of question number 5. In my diagram, you can see column number 1 and column number 2. I'm going to be talking about column number 1 first. Column number 1 has a diameter of 0.43 inches and a radius, which is the diameter divided by 2, of 0.215 inches. And we found that this column number 1 is not hollow. Its P allowable is 70 pounds. This means column 1 would buckle at this point, but would not break, meaning yield. Its PY value, which is the compressive tensile yielding, is 2,610 pounds, meaning column 1 would yield at this yielding force or higher. Column 2 we found is hollow. Its diameter is 0.60 inches and it has a radius of 0.30 inches. Column 2 has a P allowable of 130 pounds. At this yielding force, column 2 will buckle but will not break, meaning yield. Column 2 also has a PY of 4,860 pounds. At this yielding force or higher, column 2 will yield.
Here you will find our final design of our 8-foot beam that is 6.5 inches tall. You will also find its 10-foot tall columns, giving it a total height of 10 feet with 6.5 inches. Thank you. I hope you enjoyed the video.